Continuing our discussion of relativity and the wave equation, in part A of this problem, we showed that if the wave equation is written in the S reference frame using the Galilean transformation to the S prime reference frame, which is moving with constant speed v with respect to the S reference frame on the x-axis, we obtain this wave equation, which looks different from the one in the S frame. So this violates the principle of relativity, which says that all the physical laws must have the same form in all inertial reference frames. Now, part B, repeat the analysis of part A, but use the Lorentz coordinate transformations and show that in frame S prime, the wave equation has the same form as in frame S, the same form. Explain why this shows that the speed of light in vacuum is c in both frames S and S prime. Okay, now we're going to write down the Lorentz transformation equations. So for Lorentz transformation, we have x prime, it was x minus vt, it's now the relativistic correction factor gamma times x minus vt, and the time t prime was equal to t. Instead, it's now equal to t minus xv product xv divided by c square multiplied with the relativistic correction factor gamma. And this shows us that if we look at del x prime, del x, for del x prime, del x, we used to get 1 in the Galilean transformation. Here, del x prime, del x is equal to gamma. And for del x prime, del t, x prime derivative with respect to t, we get minus gamma times v. And for del t prime, del x, we obtain minus gamma v over c squared. And for del t prime, del t, we obtain gamma again, the relativistic correction factor. And now we have the wave equation written in the S prime reference frame that will be converted to the S reference frame, converted to S prime reference frame. So what we need is del E as a function of x prime t prime, del x, and that's going to be del E del x, so that's del E del x prime, and then we have del x prime del x prime del x is gamma, so this multiplied by gamma, and then we need del E del t prime del x, so del E del t prime, and then we need del t prime del x, which is minus gamma v over c squared, so this is minus gamma v over c squared. So this was plus, but because of the minus gamma v over c squared, this actually becomes minus. So that's the first equation I need, the derivative of electric field with respect to x when the electric field is is a function of x prime and t prime. Now I need the second derivative. So let's move on with the second derivative. del square E x prime t prime del x square. This is equal to the derivative with respect to x prime of del E del x. So del E del x was del E del x prime multiplied with gamma minus gamma v over c square del E del t prime. So I take the derivative of this with respect to x prime and then x prime with respect to x. And then I need the derivative of del E del x with respect to t prime. So it's del E del x prime multiplied with gamma minus gamma v over c square del E del t prime. Then I need the derivative of t prime with respect to x in the Lorentzian transformation. Okay, so continuing with this, the first term we will get second derivative of the electric field with respect to x prime, del square E del x prime squared, and del x prime del x here is equal to gamma. So here I'm going to substitute for this gamma. So which means in this first term here I will have gamma times gamma, gamma squared. The second term will be minus gamma squared v over c squared del squared E. So I'm taking the x prime derivative of del E del t prime. So it's del x prime del t prime. Now I move on here. I'm going to have dd prime of del E del x prime. And then I have this factor here, del t prime del x. Del t prime del x is minus gamma v over c squared. So I'm going to substitute, because this term also here has gamma, minus gamma squared v over c squared. I have del squared E del t prime del x prime, but the order doesn't matter. So let's write it as del x prime del t prime. And then I have this term. I'm going to get the second derivative of electric field with respect to t prime and multiply it by minus gamma v over c squared. So here I will get plus gamma squared v squared divided by c to the fourth power, second derivative of the electric field with respect to t prime. Okay. So finally I obtain from this del square E x prime t prime del x squared to be equal to the first term gamma squared del squared E del x prime squared. And then you can see here I have two of these terms. So this is going to be minus 2 gamma squared v over c squared del squared E del x prime del t prime. And the final term, gamma square v square divided by c to the fourth power del square E del t prime square. So that's the first equation I need for the second derivative with respect to x. Now I need the time derivative. So I need del E x prime t prime with respect to t, del t. This will be del E del x prime del x prime del t. And then I will have del E del t prime del t prime del t. So if I perform this, I'm going to get del E x prime t prime del t to be equal to del x prime del t. What is del x prime del t? It is minus gamma times v. So this is minus gamma v del E del x prime. And then I have the second term, del t prime del t. Del t prime del t is gamma. So this is plus gamma times del E del t prime. Now I have the first type derivative. Let's move on to the second time derivative. Del square E x prime t prime del t square. This is first the derivative with respect to x prime of del E del t. So for del E del t, I have minus gamma v del E del x prime plus gamma del E del t prime multiplied with del x prime del t and then the second term I have derivative with respect to t prime first of del E del t, which is minus gamma v del E del x prime plus gamma del E del t prime multiplied with del t prime del t. So let's take a look here. Del x prime del t is here. It's minus gamma v. So for this one, I'm substituting minus gamma v. And for del t prime del t, I'm substituting gamma. So this is going to give me minus gamma v multiplied with minus gamma v, gamma square v square del square E del x prime square. Second term, gamma times minus gamma v minus gamma square v del square E del x prime del t prime. And then I go here, this is minus gamma v times gamma minus gamma square v del square E del t prime del x prime, but I'm going to rewrite it as del x prime del t prime because the order doesn't matter. And the last term is gamma square plus gamma square del square E del t prime square. Okay, so that means I can rewrite this if I consider that these two are the same. So my final answer for the second derivative of the electric field as a function of x prime t prime with respect to t would be gamma square v square del square e del x square minus 2 gamma square v del square e del x prime del t prime plus gamma square del square e del t prime square. So I've obtained this equation. Now, what was the original wave equation in the S reference frame? Del square E as a function of x and t, del x square minus 1 over c square, del square E as a function of x and t, del t square is equal to 0. Now for del square E as a function of x prime t prime with respect to x square, I'm going to substitute this result. So that's going to be gamma squared del squared E del x prime squared minus 2 gamma squared V divided by c squared del squared E del x prime del t prime plus gamma square v square divided by c to the power fourth del square E del t prime squared. Then I'm going to substitute for del square E x prime t prime del t squared multiplied by 1 over c squared. So the first term will be minus gamma square v square over c square. So minus gamma square v square over c square del square E del x prime squared. And then I have the second term minus 2 gamma square v multiplied by minus 1 over c squared. So plus 2 gamma squared v over c squared del squared E del x prime del t prime. And final term here is minus gamma square over c squared. So I continue here, minus gamma square over c square del square E del t prime square is equal to 0. Now the first thing I notice here is that these two terms are the same with opposite signs, so they're going to cancel out. And now for del square E del x prime square here, I have a gamma square and then I have a minus 1 over v square c square times gamma square. So I can group these and write it as gamma square times 1 minus v square over c square del square E del x prime square. And for this term I have in gamma square over c square parentheses 1 minus v square over c square if I write it with a minus sign. So let's write this as minus gamma square over c square. So minus gamma square over c square, this has 1, and this has, when taken into minus gamma square over c square parentheses, minus v square over c square. And this is del square E del t prime squared is equal to 0. Now what is gamma squared? It is 1 over 1 minus v squared over c squared. So here I note that gamma squared is 1 over 1 minus v squared over c squared. So that means these two and these two will cancel out. So I obtain the final answer del square E del x prime squared, x prime t prime, minus 1 over c squared del squared E x prime t prime del t squared del t prime squared is equal to 0, which has the same form as the form in the S reference frame. So this is S frame, this is S prime reference frame. Okay. Now, in this wave equation, del square phi del x square is equal to 1 over v square del square phi del t square. This is the general form of the wave equation from wave mechanics. We remember that v is the propagation speed of the wave. Okay, so these two equations show me that v is equal to c in both S and S prime reference frames. So the conclusion is that the speed of light in vacuum is c in both reference frames, because that's the propagation speed that comes about in the wave equation, and it's the same wave equation, same form of the wave equation. Therefore, the propagation speed is c in both reference frames in vacuum. Okay, so in this part of the problem, we've used Lorentz transformation instead of the Galilean transformation. Galilean transformation x prime x minus vt is modified to be x prime is equal to gamma times x minus vt. Galilean transformation t prime equals t is modified to be t prime equals t minus xv divided by c square multiplied with gamma. So we obtain the derivatives del x prime del x gamma, del x prime del t is minus gamma v, del t prime del t is gamma, and del t prime del x is minus gamma v over c square. So we can use this in order to look at the x and t derivatives of electric field. Electric field written as a function of x prime and t prime has an x derivative. It's a function of x prime and t prime. First you take the derivative with respect to x prime, then x prime with respect to x, which is gamma. Then you take the derivative with respect to t prime, and t prime with respect to x. T prime with respect to x is minus gamma v over c squared. So we repeat this procedure for t prime for time derivative as well, where we use in this case first we have the del x prime del x prime del t, which is minus gamma v, and then we have del t prime del t, which is gamma, and we can repeat the procedure for the second derivative. That's what we did here, and doing the simplifications we found that the form of the equation, wave equation, is the same in S reference frame and S prime reference frame, and this is recognized to be 1 over the propagation speed squared in the wave equation from wave mechanics. So we realize that the speed of light is c in both reference frames in vacuum.